This morning we are in a late model JK with an LS60 L96, or it might be an LC8, I'm not sure. Basically the same engine and a 6L80. And we've done this combination many times before. This Jeep's got a lot of stuff in it. You probably notice all these lights on the dash. Well, we've got aftermarket seats and these aftermarket seat belts. So we got our seat belt light on. The airbag clock spring is broken, so we got an airbag light on. Tire pressure monitoring system's offline, so we got that light on. Just got a lot of stuff going on with this Jeep. But as you guys know, anything that doesn't work when it comes in isn't going to work when it goes out in most cases unless we fix it. So we're doing our test drive. The customer in this Jeep, I believe, is overseas, and he can decide how far we want to go with those repairs. Because we've done this combination so many times, I don't got to tell you about the 6-liter. I wanted to talk a little bit about something that really most people don't think about. And it is emissions related, so a lot of you just turn off when you hear that. But we've been seeing some Jeeps in the shop that smell like gas. Customers complain when I'm off-roading or when it's in my garage, my Jeep smells like gas. And we've actually seen a couple of engine conversions recently, not with our kit, but with some other guys' kits with aftermarket fuel tanks, and the EVAP system isn't working right. So I just wanted to talk about the EVAP system a little bit. So what is the EVAP system? Well, EVAP stands for evaporative, or evaporative emissions. And gasoline, just like water, has several states. As you know, water can be a solid, ice, it can be a liquid, water, and it can also be a vapor or steam. Gasoline has a pretty high volatility, and what that means is it can turn into a vapor at really low temperatures. And it's really those vapors that are highly combustible. Trying to light off gasoline in a liquid state is much more difficult than trying to light off atomized vapors or gasoline vapors. And that's basically what the carburetor did, is it would atomize or break up the liquid and mix it with air or oxygen so it's more combustible during the Venturi process. In any event, if you just took a bucket of gasoline and you sat it out, it would evaporate over a period of time, because the volatility of the gasoline or the hydrocarbon, when it interacts with the atmosphere, will eventually have it vapor off. So it's the same thing in your car. When you put gasoline in your fuel tank, it's not just liquid gas, you've also got vapor in there. And that vapor can boil off into the atmosphere, and that's something we don't want to have happen. Now, don't quote me on this, but as temperature rises, the speed of a chemical reaction increases. I think it's with gasoline vapor, for every 18 degrees rise in temperature, it doubles the amount of vapor that's created. And that was a problem in the early days. In fact, you guys have probably heard of vapor lock, because if you raise the temperature of gasoline too high, especially in a vacuum, it'll turn into a vapor. And that's what was happening in the fuel lines in the old cars, because you had the fuel pump up front mounted on the engine. Then you had a steel line going forward, which was getting heated up by the exhaust in the engine. And this fuel pump had to try to suck the gasoline into the diaphragm to pump it into the carburetor. So as you can imagine, on a hot day, if that fuel line was exposed to hot gas and it was under a vacuum, it would turn into a vapor inside the line, and then you couldn't pump gas into your engine. Electric fuel pumps have solved most of that. In fact, I remember in the old builds that we did 30, 40 years ago, we would put feeder pumps in the tank or on the rail next to the tank, and that would push the fuel into the fuel pump and reduce the probability of vapor lock. So the bottom line is, gasoline can turn into a vapor state. The question is, how do you handle it? Well, in the late 60s and early 70s, of course, engineers went to work. How do we store this gasoline? You got to remember, before that, fuel systems were essentially vented into the atmosphere. You had a vented gas cap. If the pressure built up, it would just vent into the atmosphere, and you had raw hydrocarbons going into the atmosphere. Gas caps are a critical part of the emissions system, and when I was an emissions inspector, that was one of the most highly inspected items, because it was one of the highest fail items, with the rubber seal cracking often, especially out here in the Southwest where it's hot. The gas cap didn't only hold pressure, but it also released vacuum. If the system went under too much of a vacuum, it had to let fresh air in so that the fuel system wouldn't collapse and the engine wouldn't start for fuel. So the gas cap is a lot more important than most people think. Early fuel tank designs were designed for maximum capacity, so when you filled up the tank, it would fill it up almost to the top. And if you did that, then you parked your vehicle on a hot day, the gas vapors expanded, you can literally push gas right out the gas cap. And I remember seeing that in the 70s where gas was dribbling down the side of a car where you fill the gas up from. So there was a pretty easy fix for that, and that was basically to leave an air gap at the top of the tank. So the fill tube would stick down about 15% below the top level of the tank. Now I'm going to mention that a lot of the aftermarket fuel tanks designed for the JK do not have these features. They don't vent properly, the sending unit doesn't read accurately, they don't have fill valves so you can fill up quickly, and I'll try to touch on each of those. You'd be amazed how much technology there is in the fuel system and the EVAP system and how little understanding there is of it. So the first order is, how do we reduce EVAP emissions? Engineers knew that charcoal could absorb and store the hydrocarbons or the gasoline vapors. So we had a charcoal canister. Literally, it was a canister filled with charcoal. And then it became, how do we get the vapor into the charcoal canister, and then what do we do with it? Well, it was obvious what to do with it, and that's to burn it off. Because if you have volatile hydrocarbons stored, you could pull that into the engine and burn it so that you're not putting it into the atmosphere and you're putting those hydrocarbons to good use. So that's exactly what they did. Most of you have heard of the purge valve on your engine. That's exactly what it does. It's connected to intake vacuum, and the calibration on these newer vehicles is set up so that when it purges, it knows that it's pulling in fuel vapors, and then it corrects the fuel trims accurately. A lot of you guys that just shut the purge valve off or don't have it hooked up properly don't realize, but you are affecting the tune and the fuel trims. So the purge valve today is controlled by a computer, and it can be modulated. So that based on many variables, including the fuel system, pressure, engine RPM, temperature, and all that, it will purge the hydrocarbon vapors that are stored in the charcoal canister where they are stored. And that way you're using less gasoline and you're recycling those hydrocarbons. Now the purge valve can be used to reduce fuel system pressure. If the pressure in the system starts building up because it's hot out, the system can purge more and reduce that pressure. In fact, the fuel system likes to be in a slight vacuum most of the time because that reduces the emissions. Now I'm going to go off on a little tangent here, but in the old days of fuel injection, we had a feed line and a return line. You guys remember that, right? You had a fuel pressure regulator on the rail, and what that would do, that regulator would limit the pressure to whatever you wanted, and whatever extra fuel there was, it would return back to the tank. The problem with that was the fuel being returned to the tank was warmed up, because now it was pumped forward, it was run through a hot engine, and then it was pumped back. And by raising the temperature of the fuel in the tank, that's going to increase your EVAP emissions. So back in the 90s, I think it was Ford was one of the first ones. They went to a single line system. So there was no return line to put warmed up or hot fuel back into the tank. Ford went to a single line system with a variable speed pump. That way they can control the fuel pressure without a fuel pressure regulator, and it was a single line forward, so there was no return line to put that hot gasoline back into the tank. Now there's other ways of doing it, including your JK. Chrysler didn't want to spend the money for a variable speed pump and a controller in the JK, so they just put the fuel pressure regulator in the tank. It's actually in the fuel pump module. Therefore you have a single line forward and it's regulated at the tank. Now that's not as accurate as a variable speed pump, but it does the job because you're regulating it way back by the pump. One of the nice things about the variable speed pump is under a heavy load you can increase the flow, and under light load you can decrease the flow. The LTs have actually multiple pumps and mechanical pumps inside the engine. It's rare to see a fuel pressure regulator any longer in modern vehicles. Most manufacturers now use other methods to control fuel pressure and have a single line forward, and that's kind of important to understand in the EVAP system. By not having that return line returning the warm gas, you're not mixing the fuel up, making it even more volatile. So it's pretty simple. Once those fuel vapors are built up on the fuel system, we want to get them into the vapor canister. And that's pretty easy because remember, the purge valve is purging the canister. It's putting it under a slight vacuum. So essentially, it just sucks those vapors into the vapor canister where the hydrocarbons are stored by the charcoal. And then when the purge valve opens and it sucks those hydrocarbons out, it makes more room for new vapors to come in. Now here's where it gets a little complicated, and I'm just going to narrow this conversation down to two popular systems, the JK and the LS, because they're really what we're dealing with here. GM went a level up from Chrysler on the EVAP system. by running a fuel tank pressure sensor and a vent solenoid. What that means is the computer can monitor the fuel tank system pressure all the time, even with the key off. When you get out of your vehicle, GM is monitoring that fuel system pressure, because if the system were to overpressurize, it can vent it, or if it's under too much of a vacuum, again, it can vent it and let air in. This is a closed loop feedback system, I call it, because it looks at a parameter and then it controls the fuel system pressure accordingly. Now, it can control it in two ways. One is it can purge, which is under vacuum, so it opens that valve up and it sucks the vapors out of the system and it lowers fuel system pressure. Two is it can vent. It can open a vent valve if the system gets too much pressure or too much vacuum. It really is a much better system than what Chrysler does. Now, what Chrysler does in the early JK and the late JK, but the Pentastar did improve things a little bit, is they don't run a fuel tank pressure sensor in the early JK. Essentially, they have this thing called an ESIM, or EVAP System Integrity Monitor. And all it really is a switch with a spring-loaded valve. So it controls pressure and vacuum with a spring-loaded valve to relieve pressure or vacuum. There is a switch used for diagnostics. Basically, that switch is pressure controlled. Now, would it be better to have a fuel tank pressure sensor, a 0 to 5 volt sensor? Yeah, of course it was. But it would cost more money. The operating system would be more complex, and Chrysler chose not to do it. So when you park your Jeep, inherently there's something called diurnal vacuum. Diurnal essentially meaning overnight, and vacuum is vacuum. So the system will go into a vacuum and trigger that switch. And that's how the Chrysler system checks EVAP integrity. That's why it's called an ESIM, EVAP System Integrity Monitor. So it can look for a large leak pretty easily, like if you left your gas cap off. In fact, it was such a problem in the JK, P0455, which is gross leak. They actually put a gas, check gas cap light on the dash, because when you had a gross leak, 9 times out of 10, it was the gas cap being loose. So rather than get a diagnostic, you just go back and check the gas cap. Well, that's fine, but the small leak is the hard part. If you have a really tiny leak in your fuel system, it has to be checked over time. So the JK uses something called NVLD, Natural Vacuum Leak Detection. When the diurnal vacuum gets created, using that switch as a monitor, it can tell if there's a leak in the system or not. Now, is it perfect? No. If you're off-road bouncing around, it can be challenging to keep EVAP emissions under control with a dumb system like this. There is no feedback. The purge valve is basically programmed off of tables to purge so much based on fixed parameters. Having live feedback like the LS and the LT is much more accurate. Having the ability to have a controllable vent valve instead of a spring-loaded pressure valve, again, is much more accurate. But the JK is really from a throwback emission system. And I have had guys complain that they smell EVAP emissions off-road. With the aftermarket tanks, we notice a lot of guys ditch the EVAP canister because they're going over whoop-de-doos, and the fuel tank is pushing raw gasoline into the EVAP canister, and the EVAP canister gets full of gas, and that's just a bad thing. And we're going to talk about one of the reasons that happens. In fact, let's talk about it now. The JK fuel tank is like most other modern fuel tanks. It has the air gap that we talked about, but there's a white thing on top of your fuel tank, and a lot of guys don't know what that is. Oh, it's a rollover valve. It does multiple things. One of the things that it does is it vents the tank, and you'll notice that there's a line going from the front of the tank back to that white thing on top of the tank. And that's nothing more than a vent to vent the front of the tank to the back of the tank, because it is a camel hump tank, so it's got high points and low points, and the fuel will seal it if you don't vent both sides of the tank. So that's really all that is, that line going from the front of the tank to the rear. Now, more importantly, there's another port. There's actually 2 more ports up there. And let's talk about the large one first, the 5/8 inch port. 5/8 hose is large for a reason, because it has to pass the vapors from the fuel tank into the EVAP canister. You don't want any restriction there. So that's the job of that hose, but unfortunately a lot of the aftermarket tanks will run like a 5/16 breather or 2 5/16 breathers on both sides of the tank, and they'll tee them together in 1 5/16. So it's literally a third the size and is restricted, so the tank can't vent properly. And that's one of the reasons you guys have a hard time putting fuel into some of the aftermarket tanks. So that's pretty obvious. The 5/8 hose transfers the hydrocarbon vapor into the charcoal canister where it's stored. Now, the third line on that white thing on top of your tank, that controls the fill valve. And what happens when you try pushing fuel into your fuel system, especially if you have a sealed nozzle. Like I remember years ago they did this in California, and now it's almost nationwide, but they got a rubber seal that seals up against the fuel neck so that vapors can't escape when you're putting fuel into your tank. Well, when you push fuel into the tank, it's got to vent somewhere. Most aftermarket tanks don't have a provision for that, and that's one of the reasons it's hard to put fuel into them. Well, an OE manufacturer has to do something. So what happens is that third line, that little line, I think it's 1/4 inch, 6 millimeter, whatever, builds up a bypass pressure, and it drops a fill valve in that white thing on top of your tank. And when that fill valve drops, it vents the tank directly to the EVAP canister. That allows you to push fuel in at a pretty high rate, and the hydrocarbons are pushed into the vapor canister and stored, so you're not polluting while you're filling your tank up. Now, it's very common for those ports to break off on top of the tank, and what guys will do is they'll tee the two together. Don't do that. If you look at it carefully, you'll notice that there's an inner circle and an outer circle. One is for the fill valve, one is for the vent. So don't mix those together. So having a fill valve and a rollover valve is a huge benefit. And it's unfortunate that more aftermarket tanks don't understand how this works and support that. I can't tell you how many times I've stood in a gas station with a $100,000 Jeep with a $3,000 fuel tank and have to drip the fuel in because I can't push it in at full speed. And while we're at it, let's talk about the fuel pump module in the JK. It's a pretty primitive module. It's not a variable speed pump. It has your pretty standard sending unit in it, which has a bob or a weight that goes up and down, and that lever then generates the resistance that is read by the computer. And as I remember, it goes in quarters. There's 4 separate segments to make the fuel level sender more accurate. But in any event, it pumps voltage into that sending unit, and then it gets a feedback to the computer system, and that tells you what the fuel level is. That's pretty simple. The fuel pump is pretty simple. In fact, the way it works is the ASD, or the auto shutdown relay, when you turn the key on, will power the pump up for a couple of seconds to prime the system. When you start the vehicle, as long as the parameters are met, which means it has to see engine RPM, because if it doesn't think the engine is running, it's going to shut the fuel pump off. If it thinks the vehicle has crashed or rolled over, it's going to shut the fuel pump off. So once all those conditions are met, it's just going to power the pump up, a simple 12-volt signal. That's the blue-orange wire in your C300 connector down by the radiator. It's just going to send a 12-volt signal back to the fuel pump and power it up. The ground for the fuel pump goes up through that same connector and then goes up to the core support. That's where the ground is. So if you ever have a fuel pump stop on you for a control problem, you can always bypass it by going to that C300 connector and jumping that blue-orange wire to power, and making sure you have ground at the black wire. So you guys are probably realizing that there's a lot more to a fuel system and an EVAP system than just having a canister to hold gas. And remember, in a JK, when you go off-road and you're bouncing around, you still got to handle those EVAP emissions, which can be more challenging when your fuel is sloshing around versus a street car. So what does all this mean? In my opinion, you should run a proper EVAP system. I see guys remove them all the time in conversions. I see them remove them all the time in crawlers. We don't want to have this complexity. And I guess if you have an off-road vehicle, you're going to go out and beat the crap out of it. You're not going to run it on road. It's not registered, whatever. Then don't run an EVAP system. But really, other than packaging, there's not a whole lot of downside to the EVAP system. And one big advantage is you're not going to smell gas when you park your Jeep in your garage. And I know a lot of you guys do smell that, because I talk to you guys and you say, yeah, I disabled my EVAP system and now I'm smelling gas. What can I do? At the end of the day, it might help your mileage a slight amount, because you're not just venting those hydrocarbons into the atmosphere, you're sucking them back into the engine and burning it, so you're gaining a little bit there. 3, you're remaining emissions compliant. Now that's obviously a big subject based on your jurisdiction and the feds and everything else. But I guess what I'm saying is if you got a regular old Jeep that you're driving around on the street, you don't want to smell gas, you're off-road and you don't want to smell gas when you're in 4-low, just leave the EVAP system in place. There's a host of codes related to the EVAP system that help monitor it. You got 455, which is a gross vehicle leak. You got all sorts of other 400 codes that'll monitor your EVAP system. If something goes wrong, it's relatively easy to fix. I think 446 is purge valve, 1 is vent valve, and they're pretty simple. The purge valve and the vent valve are just simple 2-wire components. So you check power, you check ground, and you can ohm check the component because it's essentially nothing but a solenoid. So it's a simple system, it's an effective system, and when working as intended, you'll never know it's there. You won't notice a decrease in performance, and you will not smell gasoline. So the bottom line is, if you can run the EVAP system, run the EVAP system. And I know this is probably a long, boring video for a lot of you, but some of you really want to understand this so that you can implement it in your JK, and you can use this video for a reference. We're going to take this 6-liter to the mountain, and we'll talk to you soon.